So for this question, given that 3 over 2 log 27x plus 2 equals to log base 9 of y, we are supposed to express y in terms of x. Okay, so very simple. What do we need to do here is that we try to convert. Remember that in logarithm, we also try to convert it to the same base, right? So in this case, you can see that the bases are different. One is 27 and one is 9. So what we need to do is to try to convert them to the same base, okay? If you look at the numbers 27 and 9, you will see that the bases are rather similar, right? Okay, so these are actually all powers of 3, right? They have some relationship. So applying the change of base law, the change of base law tells us, right, in case you forgot, the change of base law here tells you that if you do not like the base that you want, you can create a new base, okay, log C, and you put B at the top and A at the bottom. And the original base will go to the baseline. Okay, so based on this question, 3 over 2 log 27, we can change it. So remember that this is 3 over 2 multiplied to log 27. Okay, so this 3 over 2 multiplied to a function here. It's not a multiple, you cannot cancel like that. So log, change it to log 3. I'm going to change it to log 3. And the top is x plus 2. The denominator will be 27. On the right hand side, this will be log base 3 of y over log base 3 of 9. Okay, ma? So I'm doing a change of base. I've changed all the bases to 3. Okay, so because this is a prime number, it is the smallest number, it's easy for me to work with base 3. Okay, I always try to look for the smallest bases possible, 2, 3, 5, and so on. Okay, and then with that, you can see that log 3, 27. This is log 3 to the power of 3. Okay, which is the same as 3 log 3 lah, which is the same as, because this is equals to 1, it just equals to 3. So this number is just equals to 3. Log 9 is just log 3 power 2, right? Using the power law, I can say that this is 2 log 3. And 2 log 3 is just equals to 1. 1 is just log 3 is just equals to 1. So that also gives me 2. Okay. So with that, I rewrite my equation. My equation is 3 over 2 times log 3x plus 2 over 3 equals to log 3y over 2. Okay. So I can cancel out 3 on both sides. At the same time, 2 and 2, if I multiply both sides of the equation by 2, I can also cancel out the 2. Okay, and you see that I have log 3 x plus 2 equals to log 3y. What does this give me? It actually just gives me x plus 2 is equals to y, because I just compare both the terms. Okay, so if I cancel the log, I have x plus 2 equals to y, and with that, I'm done. Okay, I'm done. Okay, this is already the answer. All right, can now with that, how do I find the exact value for the next question? Okay, you notice that this hands it means that it's related to part 1. So over here, 3 over 2 log 27 x plus 2, you can see that it's connected to the earlier one, which is log 9y. Okay, so with that, you can see that somehow this equation, I can basically replace 3 over 2 log 27 x plus 2 with log 9y, because in part 1, I know that they are equal. I'm just going to copy paste here. That's what hence or otherwise will tell you. Basically, you're using the result from part 1. Okay, so log 9, 6x squared plus 27x minus 5. I'm just going to copy this log 9y. Okay, this equals to log 9 of 2. And using the quotient law, right, we can put these two bases together. That gives me log 9 of 6x squared plus 27x. And you can see that I'm always doing what I've consistently told you. That I always pack my logarithms into one function before I cancel off the log. Okay, so with that, I'm able to cancel off the log because they have the same base. and I have 6x squared plus 27x minus 5 over y equals to 2. All right. And that's where I can bring in my equation from part 1. Because from part 1, we know that y is equals to x plus 2. So over here, right, if this, I call this equation 1 and equation 2, right, you can easily solve them simultaneously. So I will substitute x plus 2 as y into my equation 2. And you can see that I have therefore 6x squared plus 27x minus 5 over x plus 2 equals to 2. So this is what I'm doing. I'm solving simultaneous equation. Okay. Now bring my x plus 2 to the right. This is 6x squared plus 27x minus 5 equals to 2 bracket x plus 2. This gives me 6x squared plus 27x minus 5 equals to 2x plus 4. This gives me 6x squared, 27, 2 plus 25 minus 5, 4 minus 9 equals to 0. Now, once you solve this, I think you will be able to get x equals to 1/3 or x equals to -9/2. Okay, so for -9/2, you have to check, you likely need to reject. Okay, the reason is because if you, for example, look at this equation here, if you put x as 9/2, right, this is going to fail, right? You cannot log of a negative function. So remember that when we do logarithms, the base here has to be positive. It cannot be 1. And the term here also has to be positive. Okay, so x plus 2, the reason why we reject is because they tell you that, I mean, x plus 2 has to be more than 0. Okay, example, this one will already fail. It will already fail. Okay, can? Thank you.